Hello and welcome back to Math with Mrs. Becker. Today in College Algebra, we will start off by reviewing the beginning part of Chapter 2, Section 3, which covers the topics of long division of polynomials, synthetic division of polynomials, and how to evaluate the polynomials using what is called the remainder theorem. So let's get started. The first example asks us to use long division to divide the polynomial 4x cubed minus 7x squared minus 11x plus 5 by 4x plus 5. Remember, whatever you are dividing by, in this case that's 4x plus 5, that's what goes on the outside. So 4x plus 5 goes on the outside. Our first polynomial here, that's what's going to go underneath. But before I write it, you want to make sure two things. Number one, make sure that it is in standard form. And number two, make sure that we did not skip any x values. So let's go ahead and look. I have 3x's, 2x's, 1x, no x's. So it is in standard form. We did not skip any values for x. Let's go ahead and write that underneath. 4x cubed minus 7x squared minus 11x plus 5. Now to start the long division process, what you want to do is take the first term on the outside and turn it into the first term on the inside. So in a sense, what I'm doing is I'm looking at 4x and saying, okay, what does 4x need so it can become 4x cubed? Well, it needs 2 more x's. So I put x squared on the top. Now I take x squared and first I multiply it by 4x. X squared times 4x is 4x cubed. X squared times 5 is 5x squared. Now what we want to do here is cancel the first term in every step. Okay, so as we go through this process, every time we get here, we want to be able to cross off that first term. Well, right now, if I add them together, 4x cubed plus 4x cubed would be 8x cubed. So what I need to do so I can cancel them is go ahead and change the signs of every term in the second row. So this term now became a negative, so did this. Now when I add them together, positive 4x cubed, negative 4x cubed, that cancels. Negative 7x squared minus 5x squared is negative 12x squared. Carry down the next term. Now we start again. This time, 4x needs to match negative 12x squared. Well, to turn a 4 into a negative 12, I need to multiply it by negative 3. My 4x has 1x. The term I'm trying to match has 2 x's, so I need 1 additional x. So now I take that negative 3x and I have to first multiply it by 4x. Negative 3x times 4x is negative 12x squared. Negative 3x times 5x is negative 15x. In order to cancel the first term, I go to the whole second row and I change all of the signs. So this time, both of the signs became a positive. Negative 12x squared plus 12x squared, the first term canceled. Negative 11x plus 15x is 4x. Carry down the next term. Start again. I need 4x to become a 4x. If they already match, like in this case, what we multiply by is 1. Because 1 times 4x is 4x. 1 times 5 is 5. So now when I go ahead and I change the signs, both of those to negative, positive 4x, negative 4x cancels. Positive 5, negative 5 cancels. There's nothing left to bring down. Everything divided perfectly here, so I do not have a remainder. So your solution is the polynomial x squared minus 3x plus 1. So that is long division. All right, let's go ahead and look at synthetic division. Now remember, synthetic division can be used if you have your variable and it's plus or minus just a constant, okay? So we are not dealing with exponents here, nothing like that. So if I have x plus 2, I can do synthetic division. Remember, the formula for synthetic division does have a minus sign here, so that means this would be x minus a negative 2. And that is important to remember because when I go ahead and put the number in the little box, the value that you are subtracting from x, that's what goes right here. So in this case, it's a negative 2. Now again, With synthetic division, we only use coefficients. It is a shortcut. What I need to do is make sure everything is in standard form and that I did not skip any values for x. So here I have 3x's, 1x, no x's. So you'll notice that we are missing an x squared. So when I go ahead and write this, the coefficient for x to the power of 3 is 5. I don't have an x squared. I can't just skip that. So I go ahead and place a 0 in that location. 6, x, and 8. So notice I just used the coefficients. I had to make sure I had 3x's, 2x's, 1x's, no x's. With synthetic division, you always carry down the first term. So I bring down the 5. You take the value on the bottom and you multiply it by the number in the box. Positive 5 times negative 2 is negative 10. Now you add these two. 0 plus negative 10 is negative 10. Multiply. Negative 10 times negative 2 is positive 20. Add these. 20 plus 6 is 26. Multiply. 26 times negative 2 is negative 52. If I add these, 8 plus negative 52, I have negative 44. Now remember with synthetic division, once you have gone through all of the values, and again, you multiply whatever's on the bottom with whatever's in the box, then you add, okay? So you go through and you do the same process all the way through. Once you have completed that step, the last value is always your remainder. Next to your remainder is your constant. Next to your constant, you would have a single variable, and here I'd have x squared. So my solution would be 5x squared minus 10x plus 26. My remainder is negative, so it's minus 44 goes over your divisor, which is x plus 2. So this time we use synthetic division and we had a remainder. Okay, let's go ahead and divide these. If I want to divide these two, it's going to ask you to choose a method. We are going to do long division. And why? Because it's not in the correct form for synthetic division. So I go ahead, whatever you're dividing by, 3x minus 2, that will go on the outside. Now here, 2x is no x is 1x. This is not in standard form. I don't have to add in any zeros because I do have 2x's, 1x's, no x's. But I do need to be careful and make sure that I write this in standard form. So my 24x squared would come first, followed by the negative x, and then the minus 8. Okay, let's go ahead and start. I want the first term on the outside to become the first term on the inside. To turn a 3 into a 24, I need to multiply by 8. This term has 1x, I need it to have 2, so I need 1 more. 8x times 3x is 24x squared. 8x, now multiplied by the negative 2, is negative 16x. In order to cancel the first term, I change the signs of all of the terms in the second row. Positive 24x squared, negative 24x squared, that cancels. Negative 1x plus 16x is 15x. Carried down my minus 8, start again. I need 3x to become 15x. What I need to do is multiply it by 5. 5 times 3x is 15x. 5 times negative 2 is negative 10. Go ahead and change the signs of the whole second row. When I add them, the first term cancels. Negative 8 plus 10 is 2. I cannot change a term that contains a variable into just a constant. So 2 is the remainder. It's positive, so I add. The value of the remainder is your numerator. Your divisor, 3x minus 2, that is the denominator. So your answer is the polynomial 8x plus 5 plus 2 over 3x minus 2. The last idea that we covered on Friday was explaining how to use the remainder theorem. Now, the cool thing is, if you want to evaluate, like let's just say I have p of x equals 3x squared plus 2x minus 6. Okay, let's just say that that's what I have. Typically, when they want you to evaluate a polynomial, like let's say they want you to evaluate it for x equals negative 1. What you do is you go into the polynomial and you would replace the x's with a negative 1 and calculate. Well, what the remainder theorem says is rather than doing this, we could go ahead and do synthetic division. And whatever number you would want to fill in the place of your variable, that's the number that goes into the box. Then you go ahead and do synthetic division. Your last value, that remainder, is the same thing that you would get if you filled this value into the polynomial. So again, it's called the remainder theorem because the value that is your solution at the end is the remainder. So let's go ahead and try this. So here's our polynomial, x cubed minus 5x squared minus 7x plus 4. We want to evaluate that for negative 5. Okay, obviously one answer again, just like we always have in the past. We can take negative 5 and fill it in for x. But this is so cool. We can also take the negative 5 and instead of filling it in here, put it in this little box and we can do synthetic division. 3x's, 2x's, 1x, no x's. So I can go ahead, do the coefficients, 1, negative 5, negative 7, and 4. Carry down the first term. This happens to be a 1. 1 times negative 5 is negative 5. If I add them, negative 5 plus negative 5 is negative 10. Multiply. Negative 10 times negative 5 is positive 50. 50 combined or added with a negative 7 is 43. 43 times negative 5 is negative 215. If I combine that with my positive 4, I have negative 211. So what we're saying is if you place negative 5 in for x into h of x, your value would be negative 211. Well, you know, since this is a new topic, we want to go ahead and check that out. So let's go negative 5 cubed minus 5 times negative 5 squared minus 7 times negative 5 plus 4. Let's go ahead and plug this in the calculator and see what happens. Negative 5 to the power of 3 minus 5 times negative 5 squared minus 7 times negative 5 plus 4, negative 211. Ding, ding, ding. We did it correct. So that is a review of what we did at the beginning of Chapter 2, Section 3. Now what you're going to go ahead and do is take about 10 minutes and please complete the 2.3 quick quiz. And again, this just reviews those key topics. You will do long division. You'll practice synthetic division. You'll divide where you get to choose which method and then use the remainder theorem. All right, good luck.